In this video going to explain about what is a capacitor and how its work. Capacitor gives the voltage until it fully discharges. This is the simple operation of a capacitor in electronic circuits. The charging and discharging time is depending on the capacitance of the capacitor. Now I think you can simply understand the operation of a capacitor. There are many different kinds of capacitors available, from very small capacitor beads used in resonance circuits to large power factor correction capacitors, but they all do the same thing: they store charge. In its basic form, a capacitor consists of two or more parallel conductive metal plates which are not connected or touching each other, but are electrically separated either by air or by some form of a good insulating material such as waxed paper, mica, ceramic, plastic, or some form of a liquid gel as used in electrolytic capacitors. The insulating layer between a capacitor's plates is commonly called the dielectric. Capacitor symbol consists of two parallel lines separated from each other, that is flat, curved, or an arrow passes through it. The flat line indicates that the capacitor is non-polarized. The curved line indicates that the capacitor is polarized, and arrow type indicates that it is of a variable type. In European standard, the polarized capacitor indicates using two parallel lines and the positive terminal indicates with positive symbol. In American standards, polarized capacitor indicates one is straight line and other one is curved line. Curved line indicates the negative terminal and straight line indicates positive terminal. Capacitance is the electrical property of a capacitor and is the measure of a capacitor's ability to store an electrical charge onto its two plates, with the unit of capacitance being the farad, abbreviated to F, named after the British physicist Michael Faraday. Capacitance is defined as being that a capacitor has the capacitance of 1 farad when a charge of 1 coulomb is stored on the plates by a voltage of 1 volt. Note that capacitance, C, is always positive in value and has no negative units. However, the farad is a very large unit of measurement to use on its own, so submultiples of the farad are generally used, such as microfarads, nanofarads and picofarads. For example, by applying a voltage to a capacitor and measuring the charge on the plates, the ratio of the charge Q to the voltage V will give the capacitance value of the capacitor and is therefore given as C equals Q divided V. This equation can also be rearranged to give the familiar formula for the quantity of charge on the plates as Q equals C multiplying V. Although we have said that the charge is stored on the plates of a capacitor, it is more exact to say that the energy within the charge is stored in an electrostatic field between the two plates. When an electric current flows into the capacitor, it charges up, so the electrostatic field becomes much stronger as it stores more energy between the plates. Likewise, as the current flowing out of the capacitor, discharging it, the potential difference between the two plates decreases and the electrostatic field decreases as the energy moves out of the plates. Here I am going to show how a capacitor works in the circuits. I am going to apply 12 volt to the capacitor. Now the capacitor charging from the voltage source. This is the practical example of the capacitor operation. Using a voltmeter we can measure the voltage, and now the voltage is increasing gradually. Now the voltage is reached around 12 volt. This circuit I am connected one LED and select a switch. Using this selector switch we can switch off the capacitor from voltage source and change over to the LED. Now we can see that the capacitor is connected to the LED and disconnected from the voltage source. So the LED is growing from the voltage source of capacitor and the capacitor is discharging through the LED. Capacitor gives the voltage until it fully discharges. This is the simple operation of a capacitor in electronic circuits. The charging and discharging time is depending on the capacitance of the capacitor. Now I think you can simply understand the operation of a capacitor. There is a large variety of different types of capacitor available in the marketplace and each one has its own set of characteristics and applications. It's based on construction material used for making the capacitor. Basically the types are electrolytic capacitor, ceramic capacitor, mica capacitor, paper capacitor, variable capacitor. Electrolytic capacitor is commonly polarized. These types of capacitor is connected following the polarity. Otherwise capacitor will damaged. Paper, mica, ceramic capacitor are differentiated by the dielectric materials used to construct. These types are commonly non-polarized. And the variable capacitor is used to change the capacitance in circuit. To understand about capacitor color code, primarily we must know various parameters of capacitors such as capacitor value, tolerance of capacitor, working voltage of the capacitor, and leakage current of the capacitor in general. 4 or more than 4 colors or dots are used to mark capacitors. If we consider a 4-color band capacitor, then the first and second colors marked on the capacitor represents the value of the capacitor and the third color band represents the decimal multiplier in picofarads. Additional fourth or color bands thereon represent various things for various types of capacitors. Most of the capacitors are using the letter code instead of color code. The latter code also same as the color code system. The first 2 decimal is represented the significant value and the third decimal represents the multiplication factor. Here you can see the color code chart of the capacitor. This is same as resistor color code. 10 different color bands are using for the coding. In the capacitor the color is printed in dot or band. The band is starting from the top of the capacitor. First band is for first digit, second band represents second digit and the third color band represents the multiplication factor. And the fourth band is tolerance. Fifth band represents the voltage rating of the capacitor. The value we calculated in picofarads. We can convert this to nanofarad, microfarad, etc. Here you can see the later representation in capacitors chart. You can find the code written in the capacitor and corresponding values of the code. Now commonly latter code is used for denote the capacitance value. I hope from this video you understood about the capacitor. If you like this video, hit like button and subscribe the channel for more such videos.